performed better, a student who scored 85 on one test or a student who scored 1200 on the SATs? You can compare them directly, but with z-scores, you can. A z-score tells you how many standard deviation a value is from the mean. It is a standardized value expressed as a plain number with no units. It can be positive, negative, or zero. In simple terms, the z-score tells you how far away is this value from average. It strips away the original units in scale, letting you place any value on a universal measuring stick regardless of the dataset it came from. Here's the z-score formula. Z is equal to x minus mu over sigma, where x is the individual data value you are measuring, mu is the mean of the dataset, and sigma is the standard deviation of the dataset. For example, if x is 1.2, mu is 0, and sigma equals 1, then z will be equal to 1.2 minus 0 divided by 1, which is 1.2. That is, the value sits 1.2 standard deviations above the mean. In our first example, let's say that a student had a score of 90 and the mean for the group is 80 and the standard deviation is 10. In order to calculate the z-score, we'll apply the formula. The score is 90, that will be our x value, minus the mean is 80, divided by the standard deviation of 10. So that will be 10 divided by 10, which is 1. The z-score is 1 standard deviation above the mean. A positive z-score always means the value is higher than average. Now, what if our student had a score of 65 and the mean is still 80, standard deviation is 10? In order to calculate the z-score, we'll apply the formula once again. That will be our x value 65 minus the mean of 80 divided by the standard deviation 10. So 65 minus 80 is negative 15 divided by 10 will be a negative 1.5. The score is 1.5 standard deviations below the mean. A negative z-score always means the value falls below average. Now, let's say we want to compare two students on two different scales. So student A had a score of 85 and the mean for his group is 80, standard deviation is 5. So to calculate the z-score, we'll use the formula that will be 85 minus 80 divided by 5. So this student has a z-score of 1. Whereas the other student, student B, scored 1200 on his SAT, the mean is 1000 and standard deviation is 100. So if we convert that score to a z-score, it will be 1200 minus 1000 divided by 100, which will be equal to 2. So in this case, student B performed better relative to their group. Even though the raw numbers look incomparable, z-scores make any two values comparable. So reading a z-score, if the z-score is greater than 0, that means that it is above average. The value is higher than the mean, and the larger the z-score, the more exceptional the result is. If the z-score equals 0, that means that the value is equal to the mean. There's no deviation from the center of the distribution. And if the z-score is below 0, the value is lower than the mean, and the more negative, the more unusual the result. The farther from 0, the more unusual the value in either direction. So how do we apply z-scores in the real world? Z-scores is used to compare test scores. Standardized exams like the SAT and GRE use z-scores to compare performance across different test versions and populations. It is used in finance. Risk analysts use z-scores to measure how far an asset's return deviates from expected performance, which is a key tool in risk analysis. It's also used in data science. Z-scores are essential for outlier detection. flagging data points that fall unusually far from the mean in any dataset. That's the power of z-scores. Remember the formula z equal x minus mu over sigma. Now you can compare any values, even from completely different datasets. You just need to convert any value to a universal scale using the z-score formula. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.